Hello, dear students. I am Debashri Sahu from the Paul School, Barampur. We are going to study an important chapter of chemistry, study of acid, bases, and salts. This is a continuation video of the chapter. We have already studied about the acids in the previous chapter. In this chapter, we are going to study about the bases completely. Here, this chapter is going to help us to understand what are the bases and how the bases are useful to us. Let us move into the video to watch what is there in this video. Topics that we are going to study in this video include definition and the theories related to the bases, what are the common bases that we use in our day-to-day life, naming the bases, that is how the bases are named, how the hydroxyl ions are formed from the bases, the various methods of classification of the bases, the preparation of bases using different methods and techniques, the properties of bases, both the physical and the chemical properties, and also we are going to deal about the uses of the bases. What are bases and how the bases are useful to us? What are the various components present in the bases and how the bases are different from the acids? Bases are generally the oxides and hydroxides of metals. Metal oxides, metal hydroxides like potassium oxide, potassium hydroxide, calcium hydroxide, which generally neutralize the acids to form salt and water, are known as the bases. The bases in their aqueous solution furnish a lot of hydroxyl ions. Hence, those bases which are soluble in water, they are known as the alkalis. The purpose of the bases is they can accept the hydrogen ions from the acids and thus neutralize the acids. The word alkali and alkaline means a solution which is basic as opposed to the substance which is acidic. Not all bases fit into this category, ammonia being an exception because it is a non-metallic hydride. Now you all know that alkalis are the water-soluble bases. Hence, in their aqueous solution, they contain an important ion which is known as the hydroxide or the hydroxyl ion. Sodium hydroxide consists of sodium ions and hydroxyl ion in aqueous solution. Calcium hydroxide consists of calcium ions and two hydroxyl ions in its aqueous solution. So, all the water-soluble bases are considered as the alkalis. Some common examples which we use in our day-to-day life include the caustic soda or sodium hydroxide, caustic potash or potassium hydroxide, lime water or calcium hydroxide, borax, a lot of bleaches, soaps which you are using in your day-to-day life, detergents and toothpastes are all examples of bases. So knowingly or unknowingly we are using a lot of bases in our day-to-day life. Some more examples include sodium hydroxide, which is used in the soaps or drain cleaner. Magnesium hydroxide is generally present in the antacids. We also call it as milk of magnesia. Aluminium hydroxide present in the deodorants is also an important hydroxide. Ammonium hydroxide is a very good cleansing agent and it is present in the liquid household cleaners. It is used to remove the stains present in the dresses or in your clothes. Now, what are the theories on which the bases are defined? The first theory or the RNS bases include any substance that when dissolved in water increases the concentration of hydroxide ion. These are known as the RNS bases. What are the Bronsted and Lowry bases? According to the Bronsted and Lowry theory, a base is considered to be an acceptor of a proton. Proton includes the H plus ions. According to the Lewis theory, Lewis bases are those bases which donates a pair of electrons. We have already discussed these theories in the chapter acids. So here we are going to discuss how different scientists have defined the bases according to the various theories. So we can say that we can distinguish the acids and bases on this theory as acids can be considered as the H plus producers, whereas the bases are considered as the hydroxyl ion producers. According to the Bronsted and Lowry theory, acids are the H plus donors, whereas the bases are H plus acceptors. According to the Lewis theory, the acids are electron pair acceptors, whereas the bases are electron pair donors. Now, how is the nomenclature of the bases done? According to IUPAC nomenclature, bases being the ionic compounds, they consist of a metal ion and a hydroxyl ion. The metal ion is named first, followed by the hydroxide term. Just so, as an example of it includes sodium hydroxide. Sodium hydroxide consists of the metallic ion sodium and the hydroxyl ion OH minus, so it is termed as the sodium hydroxide. Calcium hydroxide consists of calcium ion and hydroxyl ion. So for writing the formula for bases, we generally need to know the valency of the metallic ion and the valency of hydroxyl ion. The hydroxyl ion has a valency 1, while an example of metallic hydroxide, for example calcium hydroxide, valency of calcium is 2. So we give it by crisscross method as calcium hydroxide formula as CaOH whole twice. Similarly, you can name any base depending upon its valency by the crisscross method. Here we have given the example of iron hydroxide. Iron has two valencies, iron 2 and iron 3. So iron, the valency is written in brackets in the form of Roman numerals, and we name it as iron 2 hydroxide and iron 3 hydroxide. Similarly, aluminium hydroxide, aluminium being having the valency 3, we can, and it doesn't have any variable valency, so we can just write aluminium hydroxide as aluminium hydroxide. An aqueous solution of ammonia in water forms ammonium hydroxide. So NH3, when dissolves in water, it forms NH4OH, so it is known as ammonium hydroxide. Remember, ammonium hydroxide is the only non-metallic hydroxide available. Ionization in water, when we dissolve a base in water, it forms or it forms ions, which are generally the cations is the metallic ion which is present except for ammonia, and the hydroxyl ion. Here, when sodium hydroxide dissociates in water, it forms sodium ions and hydroxyl ion. Ammonium hydroxide forms ammonium ions and hydroxyl ions. Calcium hydroxide dissociates to form calcium ions and two hydroxyl ions. So this is generally the bases dissociate in water to form the respective cations and the hydroxyl ion. So how is the hydroxyl ion formed in a solution? You all know that alkalis are bases that when dissolved in water furnish the hydroxyl ion. The hydroxyl ion consists of an oxygen atom and a hydrogen atom. Together the radical consists of one electron in surplus, so we have a valency 1 or -1 is the symbol for OH on top of it given to denote the valency. So here you can see that in the diagram the oxygen O given in red ball and hydrogen H together they are forming a bond to form hydroxyl ion. So in a solution, how is this hydroxyl ion? When two molecules of water combine, then they form a hydronium ion and a hydroxyl ion. The hydronium ion consists of a coordinate bond which is formed between one water molecule and a H plus ion which is released from another water molecule. The remaining hydroxyl ion is now having one electron extra, which is given by the hydrogen atom of the water molecule. Hence it consists of one electron extra in the hydroxyl ion, so it has a valency 1. Let us see the dissociation of the strong bases. Sodium hydroxide, which is a strong base, dissociates in water with complete dissociation, that means 100% dissociation to form sodium ions and hydroxyl ion. 100% dissociation is generally a hypothetical term. If you say that any compound is dissociating by 100%, we are not sure about it. Generally, a strong bases, they undergo complete dissociation. This is a consideration. Weak bases, they go partial dissociation. So in water, ammonia dissociates to form ammonium ions and hydroxyl ions. Ammonium ions are very few and hydroxyl ions are also very few in the solution because ammonium hydroxide is a weak base. So weak bases do not undergo 100% ion dissociation. There is a dissociation percentage which is less than 33% for the weak bases. Here we have shown the diagram of how the ammonium ions are being formed. When ammonia molecule dissolves in water, then water dissociates or a H plus is released from the water molecule, and that H plus goes to the ammonium ion. The lone pair of nitrogen is now short with the help of a coordinate bond with hydrogen, thus forming the NH4 plus ion, and the left out part of the water molecule is now the OH minus ion. Now this OH minus ion is hydroxyl ion. Coming to the classification of bases, the bases can be classified on the basis of three important categories: strength of the bases, which depends upon the degree of dissociation; concentration of bases, which depends upon the amount of the base present in it; and acidity of the bases, which depends upon the number of hydroxyl ions present in the base. So these are the three important categories which we are going to study. Now let us first discuss about the concentration of bases. The concentration of the base depends upon how much of the base is dissolved in water. If it consists of lot of base in it, we call it as a concentrated solution, and if it consists of very few or very less amount of the base in the solution, we call it as a dilute base. So depending upon the amount of the base and the amount of water present in the particular solution of the base, we decide whether it is going to be a concentrated base or a dilute base. So concentration bases are generally aqueous solutions which contains relatively high percentage of the base in the solution. An example can be a solution of concentrated sodium hydroxide, concentrated potassium hydroxide, or concentrated ammonium hydroxide. Here the amount of the base is more compared to the amount of water. Whereas in case of a dilute base, the same base can be dissolved in more amount of water, where the amount of base is very less and the amount of water is very high. As a result of which the solution becomes dilute now, containing more amount of water. If there is more amount of water, then we can now discuss about the strength of base depending upon the dilution. Strength of base depends upon how many hydroxyl ions are present in when the base is dissolved in water. As we have discussed in case of acids, if there is more amount of water, then the dissociation of the base is going to be more, and hence there will be more amount of hydroxyl ion. So high amount of hydroxyl ion represents a strong base and low amount of hydroxyl ion represents a weak base. If I want more hydroxyl ion, I need to add more water to the solution of the base so that water will dissociate it into more number of ions. So a strong base generally contain lot of hydroxyl ion, whereas the weak base consists of very few hydroxyl ions. We can consider a solution of ammonia as a weak base because it generally consists of hydroxyl ions which are very few in number in its aqueous solution. So a few examples of strong base include sodium hydroxide, potassium hydroxide, calcium hydroxide, and examples of weak bases include magnesium hydroxide and ammonium hydroxide. So here ammonia is a weak base most often encountered in addition to the other anions present in the solution. Now let us discuss about the acidity of base. Acidity of base refers to the number of hydroxyl ions present in one molecule of a base. So if I dissolve a base in water, then one molecule of a particular base, how many hydroxyl ions it will release, that will tell me its acidity. Or we can also say that how many hydrogen ions it can neutralize from an acid. So it depends upon the acidity of the base. Generally, there are three different types of the bases depending upon the acidity of base. One is the monoacidic base, second is the diacidic base, and the third one is the triacidic base. In case of monoacidic bases, in the solution, if one molecule of the base forms only one hydroxyl ion, then we consider it as monoacidic. Example includes sodium hydroxide, potassium hydroxide, ammonium hydroxide. All group 1A elements generally form monoacidic bases. Diacidic bases include those bases which release 2 hydroxyl ion, whereas triacidic bases release 3 hydroxyl ions in the aqueous solution. Examples are given for diacidic base: magnesium hydroxide, FeOH whole twice. For triacidic base, we have aluminium hydroxide as the example. So monoacidic base will furnish only one hydroxyl ion, diacidic base 2, and triacidic bases will furnish 3 hydroxyl ions in the aqueous solution. Now let us discuss about the characteristics of bases. Bases generally have a taste which is called as a bitter, and generally this is for dilute solution of bases. You don't need to taste the base to know about its taste. Generally, we do not taste the chemicals in the lab. Action on the skin generally highly corrosive in nature, and some alkalis may be mildly corrosive. Before touching, we need to know about the corrosivity of the particular alkali, and when you touch it, it is generally slippery or soapy in touch. We should be using this very carefully, because generally the caustic alkalis are dangerous to our skin and they may harm our skin, being corrosive in nature. Now, effect on indicators, I have given here example of indicators: phenolphthalein, methyl orange, litmus paper and litmus solution. Bases generally turn red litmus into blue in color. The paper, you can see, it has become blue. Here the solution also has become blue. For phenolphthalein, the color changes to pink, whereas in case of methyl orange, the solutions turn into yellow. We have shown the examples in the pictures. You can also see more pictures in your textbooks where you can see the change of color of indicators when we add acids and when we are adding bases to it. Very interesting and colorful experiments. It can be done in the lab. Coming to the pH of alkaline solutions, you all know that pH is a measure of the acidity or alkalinity of a solution. Generally, the pH of water is 7 and alkalis have a pH which is greater than 7. So, the pH range of the bases generally ranges from 8 to 14, depending upon whether it is a strong base or a weaker base. The pH will vary. If it is a strong base, the pH may be somewhere between 12, 13 or 14. If it is a weak base, the pH may lie between 8, 9 or 10. So, sodium hydroxide, which is a strong base, may have a pH above 13, whereas ammonium hydroxide, being a weak base, will have somewhere between 8 and 9. Bases also conduct electricity because they have hydroxyl ion. Strong bases generally, because they furnish lot of hydroxyl ions, so they also conduct electricity. So the conductivity test can be done by the process of electrolysis. If the bulb glows, then definitely it is going to be a strong base. If the bulb doesn't glow, then it will be a weak base. The reason behind that we have already discussed: because the bases are made up of ions, they conduct electricity. Now come, let us discuss about the preparation of bases. The bases are generally prepared by direct combination method between the metals and oxygen. Also, when alkali metals or alkaline earth metals dissolve in water, they form bases. Action of steam on less reactive metals, action of water on ammonia, and also by heating metal carbonates and metal nitrates. Let us discuss about the various steps or methods of preparation. In direct combination method, metals like sodium, potassium, calcium, magnesium, when we burn in an atmosphere of oxygen, they form metal oxides. Generally, alkali metals, when they dissolve in water, depending upon their position in the reactivity series, they replace hydrogen from water and they release hydrogen gas, which can be tested by taking a burning splinter, which will produce a pop sound. By the action of water on soluble metal oxides, whenever soluble metal oxides like sodium oxide, potassium oxide, they dissolve in water, they form the bases or the alkalis. Also by double decomposition method, where the salts are used or the solution of salts are used, and here they form the basic hydroxides and generally the normal salts are being formed. This method we have already discussed in the chapter on analytical chemistry, where we have shown how the different types of salts, when they react with the bases or alkalis, they form colored precipitate. For example, the reaction given here, FeCl2, when reacts with NaOH, it forms FeOH whole twice, which gives a dirty green PPT, whereas copper sulfate gives a blue PPT. Coming to the chemical properties of bases, neutralization, an important reaction already discussed in the chapter acids. In case of neutralization, an acid reacts with a base to form salt and water. This is an example of, again, double displacement reaction. And here you can see I have given an example of NaOH reacting with HBr. Hydrogen of HBr is replaced by sodium, and here water is formed as a byproduct. So the salt is NaBr and water. An important reaction very comes in the examination of ICC board. When alkalis react with ammonium salts, they generally produce ammonia gas as a byproduct. Comes in name the gas released. For example, sodium hydroxide, to it when we add ammonium chloride or sal ammoniac, it gives sodium chloride, water and ammonia. Ammonia gas is released in the process, which can be tested by taking a glass rod dipped in HCl. It will form dense white fumes. The other properties, as I have already discussed, when it reacts with sodium hydroxide, reacts with different types of salt solution, it forms colored precipitates. These colored precipitates are a measure of identification of the hydroxyl ion present in the solution. Also, it helps in identifying the various cations present in the salt. This reaction is generally used in analytical chemistry to identify or detect the metal ions present in the salt. Bases also react with fats and oils, and they convert into smaller molecules, hence they can be used as cleansing agent. Bases lose their basicity when mixed with acids. This is because of the neutralization reaction which happens between the acids and the bases. Also, alkalis becomes less alkaline when mixed with acids. Some similarity between acids and bases. We all know that strong acids and strong bases both are corrosive in nature, so they need to be handled carefully. They tend to corrode or rust metals. Also, when they fall on our skin, they turn to burn the skin. Both acids and bases change the color of the indicators, whether it is litmus paper or it is methylene blue solution or it is methyl orange solution or whether it is phenolphthalein solution. All the indicators change the color. Now let us discuss about the basic anhydrides. What are anhydrides? If we remove water from a molecule, then whatever remains baked, we call it as an anhydride. From metal hydroxides, if we remove water, whatever remains baked, that is called as a basic anhydride. Here, from calcium hydroxide, if we remove water, then it forms calcium oxide. So the basic anhydride of calcium hydroxide is calcium oxide. Similarly, the basic anhydride of sodium hydroxide is sodium oxide. Anhydrides are also very important, and we need to know what are the basic anhydrides from the bases, and the acidic anhydride forms from the acids. Now coming to the uses of bases. Bases give soap, ammonia and many other cleaning products some of their useful properties we have discussed already, because they are dissolving fats, so they are used in soaps, detergents and cleansing agents. Also, the hydroxyl ions interact strongly with certain substances such as dirt and grease, and helps to remove these dirt and grease from the various different types of cloths or other materials. Chalk, oven cleaner are also examples of the bases. Some bases are like magnesium hydroxide are used in antacids. Also, the blood in which we are having or flowing in the bloodstream is alkaline in nature. Thank you so much for watching the video for bases. The next video will be on the pH indicators, and the last video will be on the salts. Keep watching. Thank you.